Hello everyone. So today let's solve the problem 1143, longest common subsequence, right? So here we have been given two strings. One is text1 and another one is text2. You can clearly see here text1 as well as the text2, right? So we have been given two strings, text1 and text2. We have to return the length of the longest common subsequence. Longest common subsequence. If there is no common subsequence, then we have to return 0. If there no common subsequence exists, then we have to return 0 in that case, right? So this is fine. What is subsequence? A subsequence of a string is a new string generated from the original string with some characters, can be none as well, deleted without changing the relative order of the remaining characters. See here, for example, ACE is the subsequence of ABCDE, meaning so this ACE is present in the ABCDE, right? So AC is the subsequence of A, B, C, D, E. See here, A is present, C is present, E is present here. So AC is called the subsequence of A, B, C, D, E. Simple. A common subsequence of two strings is the subsequence that is common to both the strings, right? Common subsequence in the sense here ACE should be present in this string as well, this string as well, text1 and text2, right? So here ACE is present in the text1 and text2, right? Suppose just for the example sake, right? So see here, let's consider the example seriously. See here, just give me a second here. Yeah. Now we have the text1 ABCDE and text2 ACE. So the output here is nothing but the AC, right? So output is 3. The length we have to display here. In this case, we will be displaying 3 actually. Yep. So the longest common subsequence is ACE and the length is 3. So let's go with the example 2 here. Text1 is ABC and text2 is ABC. So this one is same, right? So again, we'll consider the length 3 itself. Yeah, we have to output the length actually. That is 3. So here we have A, B, C and D, F. None of the letters matches or the characters within the string matches, right? So from the text1 matches the text2 or vice versa. So length, in that case, if it doesn't match in the question they have given, we have to return 0. So the output will be 0. Yeah. So they have given us wonderful examples just for the sake of understanding. Now we have the idea of on the question actually. Now, let's do one thing. Let's discuss the approach. So first thing I want to tell you here is we will be going with a dynamic programming, basically 2D DP, right? So just remember this. Now let's go with a, let's discuss the approach. Yeah. So let's consider same or for a change, let's consider, yeah, let's consider this one itself. First example. This is fine, man. Yeah, this is fine. Now, first what we'll do, as I've said, we'll be going with a dynamic programming, right? So first we'll create the DP table of size m plus 1 into n into 1. So this one, let's go step by step. We will be creating the DP table of size size m plus 1 into n plus 1, m plus 1 into n plus 1. M is nothing but the length of the text 1 and n is nothing but the length of the text 2, right? So dp of ij here. So very recently we had discussed the same longest common sequence algorithm in the this one in the dp based algorithm. So you can check that one as well. Yeah, I have explained this one in the detail. Yeah, so you can just check there as well. You can just check this one as well. However you are comfortable with, whichever you are comfortable with. Basically dp of ij is nothing but the lcs length of text of 0 to I minus 1 and text of 0 to j minus 1. Yeah, lcs length, basically lcs length in simple terms of this one, text 1 and text 2, right? Text 1 of 0 to I minus 1 and text 2 of 0 to j minus 1. This is fine. This is the first step actually. Second step, what we will be doing, we will be, or we will iterate I from 1 to m. We will iterate I from 1 to m actually, I from 1 to m, and we will iterate j from this one. What do we call? J from 1 to n. J from 1 to n. We'll iterate I from 1 to m and we'll iterate j from 1 to n. So suppose if text1 dot caret of I minus 1 is equivalent to the text2 at text2 dot caret of j minus 1, that character can extend an LCS. So dp of ij will be equivalent to the dp of I minus 1, j minus 1 plus 1, right? dp of I minus 1 into j minus 1 plus 1. Else we have to take the best actually by skipping one character from the either string. So we can just go with maximum of dp of I minus 1 j or and along with that dp of I into j minus 1, max of this one, right? We have to consider. So this one you will get to understand when we write the code. So this is one of the things. Now let's consider this one, the same example, right? So the same example, and let's try to implement the same thing, whatever we have discussed till now, the idea, DP idea. Let's consider this example itself, man. We have text one, I'll just write here A, B, C, D, E. Sorry, this one A, B, C, D, and text two we have here AC. Text two we have AC, right? So here we'll initialize DP with the zeros first. Then we will traverse the characters, right? So the first iteration when I equals 1, we'll consider only A, right? So we'll consider A. So this matches with J equals 1. This matches with J equals 1. A got matched here, right? So we'll propagate 1 here. In this case, we'll propagate 1. Yeah. Next, let's go with I when I equals to 2. When I equals to 2. Next, we have B. It doesn't match with the this one. It doesn't match with the C or E, right? So B doesn't match with here this one, this character C or E, right? So what we will do, DP now remains still it remains actually 0 triple 1 itself, 0 triple 1. Yeah. So this one, so DP will, I can just write it in the DP now remains 0 triple 1. Yeah, this is fine. Now let's consider I equals when I equals to 3 actually, third iteration, right? So this one matches this one. What do we call? We haven't got anything this one for B. So we are considering C now. C matches with this C, right? So C matches when J equivalent to 2, meaning this C actually, the second C, this one, right? From the text 2 actually. Yeah. Now we can just write it here in this way. DP of 2 and sorry, this has to be DP of 3 and 2, right? So DP of 3, 2 is equivalent to the DP of this one, DP of 2 and 1, DP of 2 and 1 plus 1, DP of 2, 1, DP of 3, 2 is equivalent to the DP of 2, 1 plus 1. So this is equivalent to actually 2. This is equivalent to the 2, right? So we'll continue this one until I equals to 5. We'll continue this until I equivalent to the 5. We'll continue this one until when I equivalent to the 5. So this will result in DP of 5, 3 that is equivalent to the 3, right? So DP of 5, 3 that is equivalent to the 3. So this one I can just write it in this way. So this one I3, next we'll be going with I4 and I5, right? So this one we will continue until I equals to 5. So this will result in DP of 5, 3 that is equivalent to the 3 actually, right? So the answer is nothing but the last one, the last cell, the value that is present at the last cell, right? So nothing but 3 here. So the answer is DP of MN, DP of basically the last cell, basically that is present in the last cell in the 2D DP. So this one will be DP of MN equals 3. The output that we got here is 3 actually. So subsequence is nothing but the ace here. So ace is present here in this string as well, in text one as well, and in this string as well, text two as well. Yeah, the subsequence is ace and the length is 3 that we got here. So the output that we got here is 3. We will return this one, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities. So what will be the time complexity here? The time complexity would lead to pico of m into n. Why it is m into n? Because we have to fill an m plus 1 into n plus 1 table, DP table. I said that we'll be going with the DP table m plus 1 and n plus 1 respectively, m plus 1 into n plus 1. So we have to fill an m plus 1 into n plus 1 table, visiting each cell exactly once, right? Visiting each cell exactly once. So the overall time complexity would lead to big of m into n. So what would be the space complexity? The space complexity would lead to big of m into n as well. Yeah, because we will be storing the full DP table, full 2D DP table, sorry, right? So if we need the lower space, we can reduce to big of when using the rolling arrays as well. But so we are, this is fine, man. So we'll go with this itself. Yeah. So overall space complexity would lead to big of this one, m into n. Yeah, the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So we will be making use of length of the text1 and text2 here most of the time. So I'll just assign that one to the some variable actually. Let me go with int m equals text1 dot length, as well as let me assign n to text2 dot length. This is fine. Yeah. So we have to mention parentheses, right? Sorry. Now let's do one thing. Let's go with the DP of ij, which will hold the LCS length of the text one, nothing but 0 to I minus 1 and text 2 of 0 to j minus 1. Yeah, we will be using m plus 1 into n minus 1 just to handle the base case here. Base cases actually, right? Base cases here is nothing but the empty prefixes, right? So just to handle the base cases easily, we'll be going with m plus 1 into n plus 1. Just remember this one. Let's initialize the DP array first. So 2D DP we are making use of, right? Or we will be making use of. Basically, I'll just go with DP equals new int of, as I've said, it will be m plus 1 into n plus 1 just to handle the base cases easily. Yeah. Now, after initializing the DP array, let's iterate over all the non-empty prefixes. So I'll just go with the for loop here. Int I equals 1, I less than or equal to m, I plus plus. So within this for loop, let me go with the character from text1 at the index I minus 1. So this one will be char c1 equals text1 dot char at. So this one will be I minus 1. This is fine, man. Yeah, next let's go with one more for loop here. This one will be int j equals 1, j less than or equal to n, j plus plus. So this is also fine, man. So within this loop actually, let's go with a character from text2 at the index j minus 1. So this one I can just write it like this: char c2 equals, I'll just change this one to the text2 dot char at. So I'll just go with a j minus 1. This is fine, I believe. So what if the characters match actually? What if the characters match? If c1 equals c2, if the characters match, then we have to extend the previous best by 1. We have to extend the previous best by 1. So I'll just go with here dp of I j is equivalent to the dp of I minus 1 into this one. J minus 1 we have to extend by 1, right? So I'll just go with plus 1. Yep. So else, what if it is not equal? What if they are not equal basically? If no match, then we have to take the maximum of skipping one character from either string. So this one has to be dp of ij equals math dot max of, this one will be dp of I minus 1. This is fine. J, comma, dp of I, this one will be j minus 1. This is fine as well. Yep. Now let me come out of this one entirely. Now let's do one thing. A final answer is nothing but the longest common subsequence length for full strings that is present in the dp of mn actually. Let me return dp of m and n. Yeah. So now we are done with the coding part, man. Let me format the code once and let me hit the run button. So here you can clearly see, man, the sample test cases are getting passed. So let me hit the submit button. I hope this works for all the test cases. So I can clearly see here all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.